Think math.
Take the quadratic function x squared minus 4x plus 3. Suppose x is only allowed to move between 0 and 3. Where does the value get largest and where does it get smallest? Remarkably, there are only 3 places worth checking: the vertex and the two ends. Compare those 3, and you are done. The infinitely many points in between never need to be looked at. Why only 3? The shape of a parabola gives the answer. Taking the vertex as the dividing line, everything to the left only ever falls, and everything to the right only ever rises. The single place where the direction changes is the vertex itself, so the value can never suddenly peak or bottom out somewhere in the middle of the range. Either it turns at the vertex, or it stops because the range runs out at an end. 3 candidates, and no more. First, the case where the vertex sits inside the range. With x between 0 and 3, the vertex is at x equal to 2, which is inside. Measure all 3 places. The left end gives 3, the vertex gives -1, and the right end gives 0. So the smallest value is -1 at the vertex, and the largest is 3 at the left end. The minimum landed on the vertex precisely because the vertex was inside the range. Now the case where the vertex falls outside. Change the range to between 3 and 4. The vertex is still at x equal to 2, so it is now outside. Across this stretch, the curve only ever rises, from beginning to end. So the smallest value is 0 at the left end, and the largest is 3 at the right end. Both landed on the ends. And what about the -1 at the vertex? It is outside the range, so it cannot be the answer. This is where most mistakes happen. So the procedure is always the same. First, find the x of the vertex. Second, check whether that x falls inside the range. If it does, compare 3 values, the vertex and both ends. If it does not, comparing the two ends is enough. You never have to inspect infinitely many points, and that is entirely thanks to the parabola turning exactly once. Turning exactly once is what cut the search down to 3 places. A sip of math every day here at Think Math.